It is a device without batteries, connected to the mains. It has two pairs of electrodes of iron and aluminum respectively. Without any transformer to lower the voltage, it rectifies the current with a bridge rectifier, so if you touch them you will have a dangerous electric shock. I am going to make one, but connected to a power supply of 40 volts for safety. I cut a piece of an iron bar. Now an aluminum bar. Let's bore 2 holes to connect the wires. From a piece of acrylic I will drill it to put the electrodes and a straw to blow. The black cable will go to the aluminum bar. This will be the negative pole, the cathode. At the cathode occurs the reduction. Cathode and reduction begin with consonants. The other cable to the iron bar, to the positive pole, the anode. At the anode occurs the oxidation. Anode and oxidation begin with vowels. I put water in the glass, now the electrodes. I turn on the power supply up to its maximum 43 volts. The ammeter shows 0, no current is flowing. With this multimeter it shows less than 1 milliampere, so the electrolysis produced is ridiculous. We can't see any bubble. Let's try with tap water. The ammeter is out of scale. Now it is around 130 milliamps, more than 100 times the distilled water. See the bubbles on the negative electrode. This is hydrogen. The iron is being oxidized to iron 2, and then to iron 3. These iron 3 ions along with the hydroxide anions from the reduction of water at the cathode form iron hydroxide 3, that precipitates as a light brown solid. That green solid from the iron anode that is falling to the bottom is iron hydroxide 2. The device sold on the internet works at more voltage, so the process is faster, but very dangerous. You could be asking yourself why aren't oxygen bubbles at the iron anode? That is because the oxidation of the iron is faster and more spontaneous than that of the water. This would be the reaction not observed. We could achieve it putting at the anode a graphite electrode. On the other hand, at the aluminum cathode occur the following reactions that form gas hydrogen. What will happen if I invert the polarity? Now the negative pole is connected to the iron bar, so this will be the cathode. The iron ions will be reduced to metallic iron. At this electrode will appear hydrogen too. At the aluminum bar we have the positive pole or anode and oxidation reaction will occur, so oxygen appears and the aluminum is oxidized to ion aluminum 3+, that along with the hydroxide ion form aluminum hydroxide that precipitates. The reversion of these reactions is very difficult because the solubility of iron hydroxide 3 is very low, so we don't have enough iron 3 ions in the solution to be reduced to iron 2 and metallic iron. See the iron hydroxide 3 precipitated in suspension. And now the iron hydroxide 3 precipitated at the surface. What will happen if I put some drops of phenolphthalein? There is no change in color because there aren't enough hydroxide ions in solution to increase its pH. These ions have been consumed in the formation of iron hydroxide 3 in solid state. Let's get back to the beginning. Positive iron, negative aluminum. When they come home to perform the demonstration, I put some drops of sodium hydroxide into the water. Look at the current intensity. Since sodium hydroxide is a strong base, it dissociates completely in aqueous solution to form sodium cations and hydroxide anions. The more electrolyte I put, the more current flows. More than 100 milliamps, and so we would have ruined the demonstration. I don't know why, but it reminds me a bit of Stranger Things. So we have checked that the changes of color come from the iron anode and not from the water.